the Toronto event on Tuesday night, which was a kind of epic, I don't know, digging into the sort of inner workings of all the things I've been building for the last month and a half or so. And I just ranted for what, 2 hours, Nick? Was that what it was? You know,
Yeah.
I think our heads are still spinning from that session. We
I
finally
think.
did record it though, so when Martin comes back in, we'll be able to show people.
Yeah, I appreciate Martin doing that. I probably said a whole lot of things I shouldn't have probably said publicly, but it was fun to sort of dig into it. And again, I've been in a kind of weird headspace since I got back from India. It was just kind of, threw everything off a little bit for me, in terms of my sleeping and whatever. But that was the output. Anyway, it was fun.
Tremendous.
Yeah, we got a lot to cover today because I one of the things I pushed out earlier. I've been working on this for a few weeks now, and it's a DNA system, and I wanted to get that out before I start. I'm starting a new project in the medical space. I'm doing a lot in medicine, and I actually like the medicine and healthcare space. I feel like I can have like a legitimate impact in the work that I'm doing. And every time I tell some high-priced, military contractor to take a hike, I always feel like I'm like missing out on like some financial reward that every other AI person seems to be getting. But then I realize, there's more to life than killing and maiming. And so anyway, I like the medical stuff. So I want to walk through what I did there a little bit. And there's a related project that I'm also going to show you guys in the quantum space. And this is also actually kind of some of the techniques that I'm doing with the DNA related work is directly related to the quantum related work that I'm doing. And I'm going to show you, I'm going to clean up this repo. Maybe we'll publish it and I'll show you the process of how I go from kind of, the thing I built, all the ADRs, and then making a package people can use, and that kind of last step that I do. And this is a really cool one. This one actually I've managed to get somewhere around 30 to 33 qubits, 100% fidelity, no quantum computing system required. So for lots of interesting things, you can use a kind of quantum sort of mathematics, which happens to directly map to the kind of quantum space or vector space. The two are kind of the same, which actually leads me down this path of like the idea of a hyperbolic space, the idea of vector space and latent space seems to directly map directly into our kind of mathematical reality, right? Quantum space as a kind of mathematical vector. Once you realize that all it is a vector, then you can basically map it and structure it in the same way you'd structure any other data that we're learning. So I'm going to walk through that a little bit, which will be kind of fun to jump into. But before I do, I see Rob. How's it going? What's new on the Agentics front?
Oh, all kinds of stuff. The world's waking up to what agents are actually capable of. So there's like just the messaging is remarkable to see what's coming out from the community on all kinds of channels. But then Mondweep just had the Assam chapter, the inaugural event there in Northeast India. That was yesterday morning, and it was a great success. Apparently, there's a clip from the local news station that was covering the event. So really neat. Big hats off to Mondweep and the folks there in Assam, India. It should be a really thriving
Mhm.
chapter. Tons of excitement and enthusiasm to get in and understand and apply the technology. There was a lot of representation from local government officials, and remarkably, not remarkably, but that whole region and a lot of India's all got really great uh, internet cabling. So and fiber optics. So they have great connection, great connectivity. They're all set and ready to roll. So that was nice. We have Budapest is happening just in about 10 days. That chapter's launching, and that's under the leadership of Tomas, with the help of Bensa, who's been helping them bring everything together. So that's going to be great too. What an amazing city! Tons of talented engineers there too. So all that's going off left, right, and center, and then we saw RV DNA this morning, and the chips are getting close. So there's I tell you, it's busy on all fronts.
Yeah, yeah. I'm excited. There's no better time to be in. I turn on and I saw that the former CEO or I don't know what I guess he's CEO of GitHub when it came up with a new Agentics system. It's a swarm-based multi blah 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 system to manage, Claude Code instances. He just raised $60 million. Anyway, 60 mil. And it's like
Four
nothing
generations
against
behind.
I don't it's like it's not even 4 generations behind. It's like the first 5 minutes of when I started creating it in June.
Mhm.
It's not even behind. It's like what's he how does something that could literally be built in minutes, raise $60 million with no users? But I guess that's the world we live in. I'm not chasing capital. I'm not even sure what I'm chasing. Chasing something other than capital.
Chasing the possible.
Yeah, exactly. What's possible? That's flirting on the edge
Pushing
of,
the
of
limits. Yeah, pushing the
yeah.
limits.
Yeah, exactly. And then someone's on, I got a message from someone, your stuff is nothing but a hallucination. I'm like, that's literally in the first paragraph of my GitHub. It's like, I think he was trying to insult me, but it was actually a compliment. So thanks for that, I guess. But yeah, just a reminder to everyone, like the stuff I do to Dragon's point is meant to sort of show what's possible, right? And sometimes I get carried away, and sometimes it's not possible. But I wrote this 3 years ago, well, with a little help from ChatGPT. So the idea here again, just to cover, I'm flirting in the area of the space between what's possible, what the AI thinks might be possible, and what the future 25, 50 years from now looks like, and saying, how do I create that with technology available today? Right?
Hmm.
And when you play in that space, I think for most people who are not tuning in and seeing it, they're like, oh, this guy's a nutcase that doesn't know what he's doing, or he's hallucinated himself into a corner and he believes his own hype. Maybe, I don't know. Maybe it's all bullshit. But when I do the DNA work, when I look at the comparison to other DNA systems that I have as a base, I get the same result, right? So that's a declarative, specific, deterministic. I'm gonna say just deterministic result, meaning I can run the thing. Like I'm still waiting for my DNA analysis to come back to do a comparison of what my system can do versus what the supposed state of the art can do. So we're talking days to get that result. And so I'm like, I'm not gonna wait days to get the result. I'm just gonna publish my thing now. That's how much faster this thing is. So when you look at what I'm building, and this repo is now just absolutely bonkers, but I said bonkers, you can take a drink. But the, the thing is crazy. So basically what I'm trying to do is I'm doing a mashup. I'm doing a mashup between this idea of quantum-based structure, the what I call RuQ, and the mapping of that kind of, sort of um, time, space structure directly to DNA. And I'm like, I don't know if that's going to work. But what it turned out I needed to do to make it work was, interestingly enough, create a new file format. And so and again, the AI is guiding me towards the file format or whatever. But basically, what we ended up seeing here is it's the AI first of all, my motivation is, I've got a few projects starting in the medical space. So I felt like I was going to be a little bit locked down in what I could put out there once I started these projects. So I wanted to kind of put this out before as a kind of prior art. I want this to be available for folks to see. And in many ways, what I'm doing, if you look at what we're doing collectively, a lot of what we see now emerging as sort of the supposed state of the art in February 2026, stuff we've done months ago. So if that trend continues, then there's probably an inevitable point where various health and medical organizations will clue into the same stuff that I'm seeing, and then and probably try to trademark it or patent it. So what I want to do first and foremost is make prior art. Make sure that this stuff exists so it can't be held within a kind of walled garden where only the richest, what was that movie where these guys are in outer space and then everyone else was stuck on planet Earth? I don't know. Anyway, it had Matt Damon in it.
Elysium.
Elysium, that one. I don't want that to happen. Like I don't want there to be this Elysium in the sky with a bunch of rich people and everyone else suffering. So this puts, I think, in my crazy brain, this puts the ability to sort of democratize. This is a WASM. That means you can run this thing on a mobile device. You can run this thing in a browser. You can do DNA sequencing on the compute of that's found on your laptop or desktop browser, which is amazing. I couldn't find anyone doing that, and that alone is probably a thing. So I ran the full pipeline. I used the DNA available from several sources online. I didn't do my own, but I might do that. I'm almost like scared to look at my own DNA in some weird way. But yeah, I'll probably get to that shortly. But the key here is this idea of an RV DNA. So you basically what it does is it searches for similar genes using these sort of the vectors. So what I'm taking is the different parts of the DNA or the K-mere, I guess they call it, and then I'm using the HNSW to sort of navigate the structure of the DNA. And what's interesting again is I'm not looking at the specific structure of the DNA. I'm looking at the inverse. I'm looking at the dead space in the DNA using MinCut and saying what's the integrity of the DNA and where are the areas within the DNA structure that are likely outside of the normal sort of structure. And that turns out directly told me things like where there are potential genomic issues, potential cancer related components. But because it wasn't looking at everything, it was just looking at this sort of irregularities in essence, the dark matter, the dark space, the stuff in between. And then it found those things in ridiculously low amount of time, which again, when I say ridiculously low amount of time, you'll see here in a minute what I'm talking about. So the idea of finding and structuring it in this kind of quantum-like space that then directly maps to billions of base pairs of DNA and then does that really fast. But what's really interesting about that, beyond the fact that I can even do this and it works, is the fact that because it's such a small unit of time, you can do an entire DNA analysis, from on 5 real humans in under 15 milliseconds. You don't need the whole thing. Like I'm just showing off that I can do what takes hours or days in 15 milliseconds for this stat. But the real stat here is again using this file format that takes all that information. And traditionally what you're doing with DNA information is you're using an ASCII style text file. Like seriously, they're using text, which makes absolutely no sense. So and that takes, at least a minute or two to even process the stupid file because it's text. It doesn't make any sense. So you're talking about 6 billion pairs of DNA structures in a text file. So you're millions and billions of lines in that text file. Makes absolutely no sense. So what I did is I use a 2-bit based quantizations, exactly the same sort of structure you're going to do within the quantization of different language models and AI models and so on. And then it packs that into a kind of 1-byte structure. So each gets its own little bit structure that you can then use to sort of navigate that information much more efficiently, and it's packed into a actual binary file. So basically, long story short, it makes it really, really fast and very compressed. So when you look at the structure of the typical sort of structure for DNA systems, you're going to see here ASCII, right? ASCII. The BAM is binary, but it's not a particularly good binary. So you look at how many bits per base. So a smaller amount is better. Now, CRAM's pretty good, but they've compressed it for different purposes. I needed to compress it for the ability to understand, the ability to analyze, the ability to learn, the ability to adapt. This system, the CRAM system is more like zip file, taking all that crap and putting it into as small a space as possible, but forgetting that you actually have to work within that space. So the issue you have there is the decoding. Now, don't get me wrong, 50 microseconds decoding is pretty good. So as far as state of the art goes, but I beat it by 50 times at least. So and once I get my chip, I'm probably more like 5,000 times faster. So um, this is the structures. I'm using HNSW, my favorite sort of small world navigator. Zero, I've got zero copies, so I can navigate it quick, GPU friendly if you want. Don't even need a GPU, by the way. So the trade-off is my files are larger than CRAM for the reasons I just told you, but relatively speaking, they're still pretty freaking small. So we're talking half a megabyte versus 5 megabytes according to this. I probably get smaller. Then the speed is also in a very, very important part. So, I love to talk about Elizabeth Holmes and how she was kind of, a victim of the VC world. This is another example that sort of validates her approach to sort of, on-demand, genomic and blood and related testing. It's all possible. Everything that she said she wanted to do is now possible. So the issue again, back to my Elizabeth Holmes rant, she was abused by the system, the VC world, and for all kinds of reasons. But what I wanted to say, I just want to give a shout out. Like literally everything that she said was possible is now doable, and I'm showing you how to do it. So the next part here, what else am I looking at? So WebAssembly. So WebAssembly allows you to go in here and set it up. Obviously I needed real genomic data, so I went and got the different genomes from the internet and I ran those. Pipelines, I can show you the pictures, that kind of thing. Here's how it kind of works. But yeah, this is pretty spectacular stuff. Now I put it out there, so let's hop into where am I got my root vector here.
So how do you use this? I have my 30x sequencing all of the CRAM files.
Yeah, that's
Yeah,
it.
how do you just
Pop the cram
install this
file.
and upload your files?
Yeah, and let me be very, very clear to those who are doing self-diagnosis. Always consult a medical professional. Just because it tells you you have or don't have something doesn't necessarily mean it's true. Now, what this is doing is giving you a second opinion on things or helping you find helping you find things that maybe the medical professionals didn't know to look for. Now, you should always use a medical professional as part of anything you're going to do, like especially when it comes to biohacking. But that said, yes, if you have a CRAM or any of these file formats with your DNA, you can literally point it at the system and say, "Tell me about it," and find irregularities, whatever it is you're looking for. But again, the same problem you had with the early 21andMe or 23andMe project. There wasn't a lot of guidance in kind of the okay, now I have the information. What does it mean? And people went and did a lot of crazy things with it. Just understand that there's some of this stuff is beyond our comprehension, and a medical professional will help act as a guide through that process. But Mark, yes,
I am a medical professional, so I will I'll give you feedback after I do it. The other thing to note for everyone is that both OpenAI and Anthropic have announced and released preliminary capabilities that improve clinical reasoning inside of their models. So it'll be interesting
it's
to
it's
apply what
garbage.
comes out of this.
Yeah,
Yeah.
I wouldn't touch it. I wouldn't
Yeah.
touch. I looked at the OpenAI stuff. It is absolute garbage. So what they're doing is they're using a internal linguistic model to ask the linguistic model if the information is correct, and it's like, yeah, according to me, it's 100% correct. It's
Uh,
100%, it's 100% stupid and dangerous. And every time I have a chance to consult on any medical project that are considering using it, I point out all the flaws in that system. One, it's not mathematically grounded, so it has a tendency towards hallucinations even when grounded, which is
wow.
crazy. So I would not suggest it. Now, where I would suggest it in a very narrow scope is at the last step. What's it all mean? Where's it all going? That kind of final interpretation you need to create like a report or an understanding. Use it there. But what you don't want to do is anything that involves any kind of diagnostic, anything that involves any real understanding should not be in an interpretation of a linguistic model. It makes no sense and it's dangerous. Rant over. But back to what I'm doing, I'm not basing it on linguistics. When you look at all these things that are happening in this system, these are all grounded in the concept of essentially various forms of mathematics, right? The most basic form of the mathematics being the vector itself, right? The structure of the dimension of where the information resides and its relation to other things to it in both, sort of size, location, temporal components, and various things, and that's all packed into that information. Once that's in there, then we can run other algorithms that allow you to sort of understand that and learn from that in different ways. So I'm infusing the idea of attention, like what is, kind of reasoning upon its own reasoning directly in the data set itself. Once I have got that, I can then kind of provide that to other things as a kind of infinite context, right? Where the context itself is aware. When you look at context within the structure generally, unless you're using Ruve LLM, the context window is essentially a kind of blank storage area for information that's then accessed to try to force a reasoning on it, which works for things like when you're creating a document or whatever. But the space, that context window, whether it's 200K or 3 million, is essentially a kind of dumb text dump. Now, the key here is that text dump is, one, not limited by the limitations of the language model and the context applied to it, which is, again, exponentially more computationally heavy the larger it gets. So the reason why you have things like a 200K context window versus a 2 billion context window is it's kind of an exponentially harder problem to solve the more context you have, which requires more and more GPU resources to sort of use it within the language model. So you see it maxing out around 2 to 3 million tokens. So my approach says it goes forever. It's hyperbolic in one structure, and then there's no limit in terms of the size. Whether I'm doing a few kilobytes or the entire genome makes no difference to me because it's in a space that has a center point and expands forever. That allows me to navigate it. It gives me a sort of inherent, what do you want to call it, like a hierarchy of sorts, because the very space of being round is a hierarchical structure, right? So I don't have to compensate for that like I would with a traditional Euclidean vector. Then we've got all these structures, and then I'm applying the learning directly on that kind of interplay between the vector space and the sort of graph that defines it, and then it learns from it really, really quickly. So a lot of the tools you'll see here are based around that. And I got a lot of crap in here at this point, but this has become my kind of operating system, and this is last week I was telling you guys, or 2 weeks ago I was telling you about the idea of a kind of nervous system. It is a nervous system from the point of view of speed and sort of sparseness and spiking. But for me, what this has become, and I was talking about this a little bit in Toronto at the meetup on Tuesday, this has become my operating system. And I'm not describing this as an operating system like Linux. Linux is geared towards the idea, or Linux and Windows and BSD or Mac OS or whatever is geared towards the idea that there's a human that needs to visually interact with applications, and under the covers there's sort of application components that need to interact with storage and memory and CPU and GPU, and if you get low enough there's this kind of kernel that is the direct interface between the operating system and the firmware and CPU, and then you get the firmware. The firmware is basically the last point of application that sits on top of the machine. Now, when you look at what I'm building and you include the sort of ideas of some of the chip-related work that I've been doing, I've now infused all of this from basically the chip, like directly on the silica itself, all the way up to the application and everything in between. So when you go in here and you look at like what I'm doing with my control center to optimize my computer, right? And this I built for Windows. Now, this is a kind of really good visualization of it. And as I was building this into the sort of formation of the actual inner workings of Windows, I kind of realized that I've essentially created one in Agentic OS, but the real value proposition of the system is not necessarily the OS. It's everything else. Right. It's the ability to learn, the ability to do, profiles, the ability to understand the signals coming out of the system. Now, the difference between the information you're seeing when I'm looking at like optimizing your user profile or trying to determine what the health of your PC is, right? And see here that I've been I just ran a optimization here and you see it drop the performance quite a bit. This is just another signal, right? I treat it the same way I treat DNA. I treat it the same way I treat a stock. I treat it the same way I treat an industrial system. It's just the information flowing out of the actual CPU itself. Now this sucks because I'm probably running Zoom, which is a beast. That's why I'm getting an F score here. I probably got too much stuff open too. But then I can look at those signals inversely, right back to the DNA analogy. I'm looking at the stuff in between. I'm trying to understand why my computer is lagging or booting slowly or whatever. And then that's what's giving me these sort of views, right? And by the way, I've added some coding capabilities here. So now you can spin up some agents, you can do Claude Code. I've got direct instances for built directly into the system. And I published a rudimentary version of this, by the way, on Microsoft. I haven't included the which one is it? I haven't included the chat stuff, the Claude Code and that sort of thing. But you can get a version of it from about a week ago, which is a little out of date from what I have. I just haven't got around to publishing it. I'll pop that into the text area here. All right. You guys, and I've got the Mac guys. And by the way, I had to take down the open source version. Our friends at Microsoft were a little concerned at my ability to basically inject myself directly into the core and every element of Windows. So until we figure that out, unfortunately, it's not going to be open source. So those who got it, congrats. But for now, it's not. It's no longer open source. But maybe I'll figure out something to do there with the Microsoft team. But I
A
remember when I
bridge
was
too far, eh, Ruth?
apparently a bridge too far. It's like it's a virus. Like it's not a virus in a bad way. The thing is intending to secure your computer. Like I'm running security scans on a microsecond basis, looking for anomalies in the system. Where most security systems are looking at like a heuristic, like here's a database, here's everything that we know that's bad, and compare against it. My system is not saying. My system's saying here's what the normal operating environment looks like, and here's an integrity check that says anything that's outside of that norm potentially is an insecure sort of operation within the system. So in essence, it's a kind of again hacking itself to try to protect itself. Now the problem with hacking itself to protect itself is the flip of that same coin means that it turns out Windows and Mac and Linux is particularly easy to exploit using this approach. I I'm using it to secure those environments. I prefer everyone else use it for the same benefit, but you can see why there's some concern around it. The back to my rant. I think the world of security is a complete illusion at this point. You guys are seeing the stuff I'm building, right? There's absolutely no security for anything. Now, if I can do a 33 qubit simulation, you know, what that means is now lower levels, encryption, probably sub 64 bit is completely vulnerable in microseconds. Now, what I don't know is what that looks like when you start doing a cluster of these kind of machines, which I hypothetically could do through this app that I've created. I could go in here, create a marketplace option, and we could create, EdgeNet, and suddenly everyone using this app on the Windows Store is contributing a bit of compute to solve some sort of distributed problem, like steady at home style for DNA or whatever purpose that you want to do little by little, right? So there's so many opportunities here. It's almost mind-boggling to think about. Let me pause for a moment. I just ranted for a half an hour. Does what I'm saying make any sense, or am I pulling a Tuesday, Nick? And by the way, Rob, we missed you on Tuesday.
Yeah, it was just another snow day up here, and it got 2.5 hours away. So
Yeah,
yeah,
no, I
that was
hear
a
ya.
shame. Next one, definitely.
Yeah, I know you're in the snowiest of snow belts there,
Yeah.
and yeah, but I figured the lake's almost frozen. It should be so snowy these days. Oh,
Almost
Martin, you're back.
Yeah, I've been here for, I guess, about 10, 15 minutes. I was just going to point out that we did record it. I haven't uploaded it yet. I will do so.
How many things did I say that are going to get me in trouble, you think?
Wait, if you want to edit it before it goes up,
I
but
don't
you
know.
usually
I'm
don't.
I don't. I've got no filter. Um, I don't know. Someday I'll look back on it and we'll be like, he's a crazy person or something. But yeah, put it out there. I think it was actually a pretty good, as far as like a summary of all the things I've been working on for a while. I think it turned out to be a pretty good sort of brain dump.
Yeah, I think if we can get those out, I mean, some sort of reference format, that'll help a lot of people, especially newcomers who are trying to navigate.
Maybe we upload it to the our video.agentics and let the video.agentics site do its thing where it kind of
Well, certainly
chops
we
it
should
up.
do that, but for discoverability, it's better on YouTube, which reminds me, not that we need to talk about it now, but I need access to the Agentics Foundation YouTube
Oh, sure.
site.
Yeah,
Yeah.
I can get you that.
Yeah,
Thank
move
you.
her, Leandra.
Yeah, we've been and Matt and Nick and Dury and a whole team have been working hard on that. I think Chris has been working on the a new job board. Everyone's looking for work, and there's a ton of work to be had in Agentix, but it's not distributed evenly. So we're looking at a way to yeah, we're looking at a way to make that a little
That's the future.
more democratic. I don't know what the right word is.
Well,
Accessible.
yeah, there's a dire need
American.
for a lot of talent. So, and the talent runs a little bit of a spectrum, but my gosh, this community has an awful lot of the abilities and insights that projects organizations are looking for all around the world right now. So I think it's just amazing. It should be really exciting, and it's good work by Chris.
Yeah, we just need to get organized. Yeah.
Yep.
Yeah,
Well, Chris has got it pretty well sorted there.
Yeah, organized. I'm organized in my own little crazy, unorganized way, but
Well, individuals, I think, are organized. It's just trying to collectively.
yeah, I hear you. But we're always looking for volunteers. So if you are interested in helping in any way, contributing to various causes, I'm thinking maybe we do a healthcare focused hackathon. I've got all these tools. We've got Antoinetta, we got others who are in the are hopefully as passionate as I am. We should try to do something to have some impact on
Absolutely,
for
absolutely. Let's do
wait.
it.
How are you doing, Antoinetta? It's good to hear from you.
Yeah, doing great, and I'm so happy to see all your stuff around, biomedical stuff, the DNA, the healthcare system you presented last time. Would love to learn more.
Yeah, I've got a tutorial. I got to talk to the team on whether or not I can share it, but I've got a tutorial on how to scale your healthcare environment to 50 million concurrent users, which is it would be interesting for a lot of folks out there. But unfortunately, that is a paid consulting gig, so I would have to get their approval, and they may not go for that. But the good news is I'm working on a project, thank you, from our Agentix crew that is directly on 50 million healthcare patients. So that's the biggest, probably the biggest project I've worked on in Agentix anyway at this point.
This
So
is
when people
amazing. This is absolutely amazing. I used to have in the past a project that I remember seeing last time there was a section which talked about patient similarity when you were showing this. This is such an amazing possibility because doctors don't remember everything about every single patient, but if the data is there and you can actually map who is most similar to whom, you can actually leverage successful patterns of treatment versus non-successful to guide as a second opinion, as you said, as a digital opinion, options for patients. This is so incredible. Also, this fast processing of the DNA and interpretation, I mean, that can help tremendously in oncology, for newborns with various problems very early on. This is tremendous what you're doing.
Yeah, you're right. And a lot of what the biggest challenge that a lot of medical organizations have right now is most things are built for the average. They're working on a kind of bell curve. And they're saying on average, if you fit this demographic profile, you're X this, X that, then you fit the average for that particular sort of demographic. But most of these systems, even DNA-centric systems, aren't being designed for you, right? Because it's prohibitively expensive. So think of if you're a large healthcare provider, and some of the largest have like literally 100 million sort of patients. And now, if you were to create an agent for each one of those patients and say, how can we understand each one of our patients in a way that's intimately designed for them? It'd be using traditional AI technologies would be ridiculously expensive. Like let's say conservatively, you can do that for $10 a month, right? You've got an agent or two running for each of your patients, understanding their particular requirements. 100 million times 10, you've got $1 billion that you're spending a month. No one's going to spend $1 billion a month to try to understand their patients better. Now, what's interesting about the approach that we've taken here and in the technologies that we're implementing, there's no incremental cost. Like if you buy the chip or the appliance, you spend the $599, you could comfortably do 100,000 agents running all the time, and it's just cost you $599. The cost now, so for that's 100,000, and then 100 million is a lot more, but it's still not $1 billion. It's probably still in the $100,000 less range to have real time, always on analysis of every single one of your patients, looking, optimizing, understanding, and being there to make their lives better. Now, what does that mean? That means a lot, right? It means that these companies are hopefully more profitable, but more importantly, I don't even care about their profitability. It means that their patients are more healthy, right? And that's the thing that really matters. And cost is no longer a limiting factor. So we're literally living our wildest tech, Star Trek dreams with a tricorder that instantaneously knows everything there is to know about that person. Now you mix in some of the other technologies you've seen us be using, like the Wi-Fi decompose that I was showing you guys a few weeks ago, and suddenly you're able to understand other sort of biometrics, how what their internal workings are based on the fluctuations of a Wi-Fi signal. So we're living in strange times. But Antoinette, you put me in a rant again.
No, I love it. I love it. The only limitation is, as you know, personal health data, it's difficult to get. And so I'm just wondering, for this hackathon, I mean, people have donated their DNA sequences. We can get some of that, right? But I don't know whether we can have a good database of healthcare data. But I wonder whether we can synthesize based on various patterns that we see. So it's synthetic data to analyze rather than real, right? So I wonder, what's the basis on top of which we can do this?
So there's a lot of sort of anonymized data, but there's a couple things to note. And one of the reasons why you'll notice that I did a WASM, you guys know I love WASMs, or WebAssembly modules, or whatever they call it. If they can exist independently of a central cloud or infrastructure, that means if I want to use my personal information, my DNA, the most private stuff I can possibly give is my internal sort of operating system, right? The code to me. I don't necessarily want to give that away either. And if you look at like the 23andMe's, being bought by like a hedge fund and stuff, ultimately all that data is going and being used against us. Let's be honest. Now, what this does means that the data never leaves the browser, it never goes back to the home ship, it never goes back to the cloud. I can do all that, in an environment completely segregated and segmented from the rest of the internet. This thing will work again on my little device here. No internet required.
Yeah,
right?
that's absolutely huge because privacy is top concern, right? In these cases, because your social security, your DNA is your social security, right? So if you open it up, there is no other identity than that.
Your DNA is your social security,
Yep.
your social
Yep.
insurance, your most valuable thing. And
Yep.
yeah, and we
And even if you don't use the whole DNA, but if there have been many studies actually that if you take a few mutations combined with the demographic data and this and that, it's uniquely identifying a person.
yeah, exactly. And that, oh, what did I do?
We lost him.
It's a great idea, but I was going to ask Mark because for this Vermont workshop or whatever, I believe I saw that it is going to have a biomedical emphasis. So I actually signed up. I would love to hear more about it and sign up for all kinds of whatever experiments.
Well, I don't know that we're going to have a
Mark, I have my
biomedical
DNA as
emphasis on.
well, but I'm guarding it too, and the whole family. It's like that's the most precious thing.
I know that there are a few doctors coming, so I'm a doctor. I know a couple of
Awesome.
doctors are coming. But I mean, I'm definitely going to play with this. I'm doing a lot of stuff in the medical field. I'm gonna play with this new DNA analysis for sure.
Mm-hmm. Excellent.
Did Roof Opus watch this?
He said he will.
Yes.
I couldn't.
Yes,
Oh, is it
I can
already?
say I will send the I will send the link in the chat.
Oh, the roof
Does
factor.
it does anyone have an update for the Vermont trip that they want to talk about?
Well, I can say that there are now 4 bedrooms left, only in the Red Clover Inn, where we're doing the main stuff. So if you're thinking about going, I would encourage you to do it as soon as possible. There is a backup hotel, but it's just not on site. It'd be more fun to be on site.
So that's pretty much booked up then, eh, Mark?
There's 20
Busy.
bedrooms total,
Yep.
so
We're all
almost
okay.
booked up.
Very good. Excellent. That's going to be an incredible event. I've spoken to a few folks who are coming in from quite a distance, so will be
I think
nice.
it's going to be awesome to have all that time together.
Yeah. Yeah, that's coming up soon too. Just a month away. It's almost spring. I know you don't yeah, you like the winter to last as long as possible down in Vermont, but
Oh, it's actually going to be wonderful. The problem about this time of year is that sometimes it's really bitterly cold, but it warms up a bit. But it's a great time for skiing, snowboarding. The entire mountain will be open.
beautiful. Brad, you have you worked on some and have a chat going in the WhatsApp on your AISP work.
Yeah,
Want to touch on that a little?
I might need a couple of weeks. I'm doing some formal benchmarking and some integrations and course writing right now. So not quite ready to just add pocket here, but thanks. I might pass the showcase to Dragon.
Hey guys, sorry about that.
Hey, really?
I might have had a little too much running, and Zoom's a pig. So yeah, I only got 64 gigs of RAM on this thing. I probably need a little more than that.
Double up.
Sounds like you might have to optimize the computer somehow.
Yeah, well, I think it's beta. It's beta. It's gonna alpha more might be the better term here.
Yeah, just while you're away, we're just Mark was just mentioning there's only 4 rooms left in Vermont.
Oh yeah,
Well,
yeah. I'm looking.
there is
looking forward to that.
backup. There's more than 4 rooms left. There's 4 rooms left at
sorry.
the main hotel.
In the main hotel, right?
Yeah.
Yeah, looking forward to that. I know my kids are looking forward to snowboarding on the hill. I'll be skiing, but I'm not exactly the most crazy skier in the world here, but I like skiing. How's the snow looking like in Vermont?
Mac and I went out this morning because it was a powder day, so it was exceptional.
Oh, nice.
Yeah, the
Yeah,
entire mountain's open. So it's we yeah, a lot of the US has had a very dry year, the West. But we've had a great year.
yeah. It's we've had an incredible amount of snow here in Toronto too. It's I don't know. We had that storm a few weeks ago where we had like 3 feet, but
Yeah.
that doesn't. That's I think that's the most snow we've ever had in a storm. They tell me. All right, where do we leave off? We were talking about healthcare, and Mark, you're a medical professional. What's your background? As you know, you say you're a physician.
Well, yeah, I'm a physician, trained as a physician, halfway trained in emergency medicine. But I switched over into AI initially during my medical training, back when it was a dirty word. So I started working on it in '97, and so started a company in clinical decision support in 2000, based upon research I was doing, and that's when I left practicing and haven't looked back. So yeah, I've done a bunch of things in healthcare since. I've done after I sold that company, I got into biopharma drug development, targeting aging, which I think is another area that with the help of AI we will be able to solve probably in our lifetimes at the rate that things are progressing. I mean, the biggest problem in drug development, just talking about that for a moment, is that clinical trials take such an incredibly long time. But if we can do computational biology and accelerate time, deep computational biology of the entire body, which we're getting more and more progress, massively toward that, then we could effectively run clinical trials on anything and accelerate time on that and make scientific discovery. And that's what's going to happen. And ultimately, we will engineer out aging. It'll be as crazy to die of aging as it is now to die of an infectious disease, right? But that's how 100 years ago it was natural to lose half your kids in before they reached adulthood. So,
It's awful.
this is where things are going to go
Yeah.
with AI helping us.
What's and I completely I'm drinking your Kool-Aid. And when you look at like structure and the sort of, you're describing the sort of temporal element of the computation. And you should know by now that I'm all about speed, right? I'm looking at that nanosecond and microsecond increments to do millions of billions of things that are very narrowly focused but very powerful in that narrow focus, right? Looking at a single piece of DNA while 1,000 other agents look at every other piece of DNA kind of approach. But what's interesting, so right now when I talk about these chips, and I love it because that's my thing at the moment, but what we're looking at here is 12 nanometers, right? So a 12 nanometer chip, and I've been able to pack 253 because I like prime numbers, cores into basically 3.5 centimeters. Now, what's interesting is at 1.8 nanometers, which is the latest chipset that came out from Intel literally a few weeks ago, we dropped that to essentially a grain of sand, 8 atoms across, which is, amazing. You can fit 1,024 cores in something that's literally a grain of sand and powered by static electricity. But now let's assume for a moment that that level of sort of shrinking and optimization continues. There's no reason to believe until you hit the kind of atomic wall, right? The atomic wall is essentially anything under the size of DNA, right? And the reason why DNA is the size that it is it's shrunk to the point that it can't get any smaller. It's hit the atomic wall. But it's above the atomic wall, which means that you can, hypothetically anyway, take and keep shrinking the silica down till it's literally smaller than a grain of sand, capable of being injected into each and every cell and acting as a kind of brain inside the cell. And that isn't even, that's probably 5 years off. Now we can take that a step further and say, what does 10 or 15 years in the future look like? And even maybe conservatively 20 years. Well, we're now at a point, if you keep shrinking at the same rate that everything else is shrinking, that you can infuse that computational system directly into the DNA itself. And that's when things get particularly interesting. Aging, in essence, is a mutation of your DNA. As you get older, you collect more sort of random bits and pieces of information that your body isn't capable of seeing and understanding. The human body doesn't have min-cut. It doesn't have the ability to see how these things influence and change based on the baseline. And then it just assumes that the new baseline is that new sort of collection of garbage that now has been, infused into your DNA. By infusing the DNA with a sense of self and reasoning, which is just mind blowing, you have the ability to say, has this diverted from the base? And if it does, it can then reprogram that base in essentially real time. Moreover, not only can it reprogram it to be your optimal version, it can be your optimal version of your DNA, saying out of all the various forms and structures of DNA, what is the one that's most structurally appropriate for you?
Yeah,
In
you're
your particular.
completely onto something. So what happens is it's the epigenome. So our genome doesn't change. The epigenome changes. But you can actually take your cells. We know this. Experiments have been done. You can take your cell, any cell in your body, basically, and you can reverse it to an embryonic state by effectively resetting the epigenome. And a guy named Yamanaka won the Nobel Prize on that several years ago. And so now a whole bunch of scientists are using, I would call these primitive technologies compared to what you're working on and the thought pattern you're taking, where they're using chemicals effectively to try to reset the epigenome. And the problem is if you do that globally across the body, and you'll have cells that reverse to embryonic states, and then you'll get tumors because they don't know what they are. So you have to go do the proper level of epigenetic resetting. You don't want to turn a neuron into an embryonic cell, right? You have to do the right level of epigenetic reset for different cell types. So
That's you stated it better than me, the world's most
You didn't even,
dangerous hacker. But
Brew, you didn't even bring up my stuff. I'm all about this science stuff.
Yeah, Kobe actually, and I should mention Kobe because Kobe has definitely been an inspiration in terms of what you've been doing. So tell us about your DNA hacking and whatnot. Nope, we lose you, Kobe. All right. Well, while we wait for
But
him,
by the way, Guy had mentioned, but I also wanted to mention that David Sinclair, who is a professor at Harvard, he just got FDA approval to start clinical trials based on he's big in this longevity and field. So
and specifically this.
three of the Yamanaka factors actually.
Yep.
So this is tremendous.
Well,
We're going to see soon how things are going.
So when Rue met me, I had put together the largest microbiome Neo4j graph database, I think, in the world. So that's kind of how I started out. But I've been successfully simulating phase 3 trials at 99.99%, meaning if they should do it or not do it. I've done like 30 of them at this point. So it's about 500 million in savings to them. Like published ones. I work with the University of San Diego, my two partners there. And then we have a mitochondria test too that we invented with take like a little dab of your blood on your finger. We do that too. So I just started to put microbiome data, mitochondria data together. And we already submitted stuff to the Michael J. Fox Foundation on like, because it's all patterns, just like you were talking about predicting Parkinson's disease 30 years in advance. And then also why L-DOPA doesn't work for half the patients. And I just ran simulations and figured it out that it's actually a microbiome that eats 50% of it, 30 to 50%. And they came up with kind of a cure to allow that, because there's like a type A and a type B. And so I've been able to come up with tons of cool things. And I downloaded the 39 million PubMed papers, vectorized them, similar to like what we're talking about. So everything's cited and sourced. I think my systems wrote like 450 white papers. I don't know what the heck it's talking about, but they do. And it's just finding so many cool and like amazing things, even predicting when people are going to die, like from their microbiome, because I have so much data that I can tell where the levels are when people are going to get sick from a cold or die. And because you have your age and then you have your like body age, which is really your gut, and it's you can reverse it. So you can predict. I can predict diseases people are going to get and everything from it, just from all the data, because every data I have is from people with diseases. I have their medications, I have their regimens, which is very valuable. Not just having like microbiome data.
Did
This is
you
amazing, Colby. Do you have anything open source? Is any
No.
of your work
I can't give any of the
available?
data away because it's from the college.
well,
The only person that's ever got to look under the hood is Rue.
And don't worry, Colby. I didn't. My stuff is completely independently built.
Yeah,
And I
no, I
gave,
know.
and I because I'm insane. I gave it all away. So it's Colby and I think are converging on similar theories through different means. And mine is based on this sort of binary package format. Colby, you should try that, by the way. It
Okay.
seems to be particularly well suited if you're doing like large groups of sort of concurrent DNA.
I like words of the day. You know that. You saw my message to you.
Oh yeah. Don't forget about the Gaussian splats, man. Gaussian
No, I did
splats.
it. I did it. I already did it. I already rewrote the whole thing. I sent you a message last night at 9 p.m.
I missed that. I have to check that out.
Yeah, it's okay.
I see John's got his hand up here. John, how's it going? Good to see you.
Good to be here. As somebody who lives the anti-aging, I'm going to be 83 this month. I've got a birthday coming up.
You look great.
I have
breaking up a little bit, John.
With the command of metformin and NMN daily. Huh? I'm sorry?
You're breaking up a little bit. Maybe stop your video. Improve your connection.
Okay, so
say that again.
Okay. So I have experimented with some of the chemicals that Mark talks about, two of them being metformin and NMN, which were recommended by David Sinclair in his anti-aging book. And I can tell you that it brought my hearing back. I was losing my hearing, and my hearing came back with a vengeance. So some of that really does work. The thing that I think I can contribute to this discussion for you, Ruve, is that David Sinclair, who is one of the thinkers in this area, asked the question that when the epigenetic reset occurs, which Mark was talking about, so there's two levels. There's the DNA, and then there's the epigenetic layer. It has been compared to having the DNA as digital and the epigenetics as analog. So the gunk that you were talking about builds up at the epigenetic layer, so the theory goes, leaving the DNA untouched. So David Sinclair's question is, if the epigenetic layer resets to its, for lack of a better word, fetal state, where does it store that? And where does that appear? Because they can't seem to find any evidence where it is. So it's kind of the ghost behind the curtain. And my intuition, which is just my intuition, is that it lies in a quantum state, which cuts back to your stuff.
That's exactly what I was thinking.
Yes. So that's where I think the rubber meets the road. So with that, I said a piece. Thank you very much.
So John, to test your thesis, what you need to do is you need to go into Claude Code or whatever your preferred vibing system is, and clone my repo, specifically my DNA tools, and explore that rabbit hole. Because what I've done, and I didn't play up the quantum parts because I thought people might think I was a maniac, which you probably already do. But what I've done essentially is take the quantum mathematical structures of qubits and other sort of components, and then I applied it as a mechanism to understand and structure the sort of adjacent information of the DNA. So the DNA in my system acts as a roadmap of sorts that guides towards a secondary space, quantum space that stores the detailed information that I can then draw upon in almost instantaneously to help guide and correlate the information that exists within the DNA. So the DNA is essentially just Google Maps. That's at least that's what I was trying to do.
I think there's something to really probe here. I'll try to get my primitive vibe coding skills together and see if I can get anywhere.
Yeah, Vibe DNA. And by the way, I also have a synthetic DNA system. You guys remember, it was about a year, more than a year ago on one of these sessions, we created a system that would basically create synthetic DNA. And then I shipped it off. I gotta find that vial. I shipped off my little output to a lab, and it would cost like, I don't know, it was like a few $100. And they sent me back a vial. And apparently, I don't know, in this vial was a DNA structure with RUV embedded in the actual DNA. Now, what the hell am I going to do with that? Who the heck knows? And don't dare open the container because it looks like a bad idea all over it. But the fact that I could do that a year ago says something. Now, what can we do now? Is I don't even know.
What we need to do is get everybody's data and put it together, because that's where the patterns come from.
Well, we can use a transfer learning system that we've devised. Now, right now we're using that.
We can traverse, so we don't share the data, but we still can utilize each other's data.
That's what the transfer learning is doing. So the transfer learning allows you to export the trajectories and the final sort of optimizations. So think of that pathway between, when you touch something and when you know that it's the table, right? That's going to a certain part of your brain, and that's almost an instantaneous sort of response. My table's sort of rough, it's wood, whatever. So similar idea. I've trained the pathways. I can export those pathways, and then you can import those. Now, the most obvious use case for that right now that I'm using it for is when I have multiple Claude Flow instances, and I want to share the learnings from repo 1 with repo 2, but I don't want to export the information to how I optimize it, because there might be keys in it. There might be other things that I don't want made available. Similar to, I don't want to share my personal identifiable information or my DNA, but I want to share what I learned from it. And you can export all that. And that's what RuVector does with the export option.
I use nodes and edges. So the node gives you the authentication of what edges you're allowed to traverse, but you can't save the data. So like a search, if we were trying to match patterns, would allow you to traverse that data to match patterns, but it wouldn't pull the data all back in. It would just give you the results.
Smart. Yeah, that's really smart. So Colby and I are following the same rabbit hole. You're just you're in rabbit hole B. But yeah,
I'm just saying. I have microbiome and mitochondria data in 60,000 patients. That's like magic. It's like we're gonna start getting blood tests and DNA, and nobody has that data. It's pretty cool. So if anybody else on this call is a doctor or has data, I'd love to get together with my PhDs and see, because you can kind of compile that together and come up with really cool things if you get people to take them all.
Well, I need to connect you with my uncle.
The patterns come from them taking all, like, you have to take the microbiome test, the mitochondria test, and then other tests, because I have to have patterns, and then I can do like KNN inferencing, where I can start to make assumptions on other people to do it, which is still approved that you can do, but I have to have enough patterns.
All that exists within RV DNA. You guys can just pop open Claude code and you can do exactly that. All right, I'm gonna jump here to the next stage here. I want to show you guys something, how I came up with a quantum system. Now, what this is going to show you is the kind of
system. What was it? Quantum, you said?
Yeah, quantum. So what I want to show you here is sort of how I went from vibe to something functional. So hopefully you guys can see I've got two screens. I know I discovered I can share two screens at once, which is cool. So on one of the screens you'll see here, I'm moving it up and down. I'm seeing the final PR. And what this is essentially doing is giving you sort of the final state. But I want to show you the primary state. And I did this on my phone, just kind of messing around. Now, at first, I'm just, asking questions and trying to figure out what I want to do next. And I know that my MinCut stuff can be, applied to various, different approaches. So can I use MinCut in various libraries to reverse decipher various blockchain transactions? To be honest, I'm just figuring out if I can hack Bitcoin. is what I was thinking at the beginning. And that took me down a completely crazy rabbit hole, and you're gonna sort of watch the rabbit hole unfold here. So root vector can be used for blockchain forensics. It can be used to decipher tumblers and figure out who the bad guys are and who's manipulating the system. You know what? I hate Bitcoin and blockchain, but I was doing this mostly out of spite. And then I realized, you know what, that's not probably the primary motivation for the things I want to create. But anyway, it was interesting to sort of dig into it. And so looking at this, there's a ton of stuff you can do to basically de-anonymize blockchains relatively easily. And that's what this is telling me right now. So it says I can use the graph structure, I can use the min-cut to do analysis, I can use the GNN to understand and classify, I can use the core, and I love it. It found my prime radiant. Thank you, Azanoff. And to use for other parts, so it's exploring my OS, if you will. And then it's saying here's our other tools. Bottom line, the min-cut in temporal system can provide primitives to do it, blah, blah, blah. I'm like, all right, can we use UQ capabilities to enhance state of the art? And I'm always asking about state of the art. State of the art means I've got a baseline to compare what I'm building, and I'm going to beat it. And now I'm so comfortable in beating state of the art, and in the same way, some of you guys were describing the things you're building. It's almost like a daily occurrence. Oh, I'm 100 times faster than the current stated world record of whatever. And there's so much of that. It's like at a certain point, you're like, who cares? It doesn't matter. What it matters is what you can do with it. So then it says here that I can look at subpominal dynamic min-cut for transactions. I can look at a bunch of different things, right? So now what I'm doing is I'm infusing quantum capabilities, virtual quantum capabilities, directly into the system and trying to get a sort of improved output because of it. And then we see we can do various other options, et cetera, et cetera. And then you see theoretically, how could this be used to break modern cryptography? You're getting a little glimpse into my brain here. Then I'm asking, what does Shor's algorithm look like in 50 years? So the Shor's algorithm is the key algorithm in quantum computing that at scale will allow us to basically understand pretty much everything all at once, in essence. So tell me everything. Tell me every possibility of a crypto, sort of encryption algorithm, and give me the answer to what it is, kind of problem. So hard, big, broad problems. So then it's saying I do a bunch of things, blah blah blah. Then it's telling me what Shor's algorithm probably looks like in 50 years. Remember, I'm always reverse engineering, and when you look at reverse engineering the future, you can't go too far in the future. Like when you go to 100 years, it just becomes nonsense. The best reverse engineering is in the space between 25 to 50 years from now, because the AI perceives it as something that's relatively attainable using the technology that's available today, but has yet to be developed. It's that gray space of hallucination that exists in between what does exist and what should exist, right? And that's why you can build it. So in this case, it's saying there's some wild cards. You're saying that basically in 80 years, it's just is what it is, kind of thing. And then I'm like, I'm going to check my status because I have a little swarm running in the background. So when you're using the web version of Claude Code, it kind of goes dormant. So you have to wake it back up. Even it's not dormant. It's the way they built the web system doesn't include persistence in it. So the agents continue to run, but the updates don't continue to happen. So you occasionally have to go in there every 10, 20 minutes or whatever and just kind of wake it up again. And I'm just typing check status to do that. Then I woke up. It said it finished. How much larger beyond the 25 qubit simulator can we push root of Q? Like 1,000, like 100. And remember, when you're looking at qubits, it's a logarithmic structure, meaning that going from 25 to 30 is like several orders of magnitude more than going from 20 to 25, and so on and so forth. It's an exponent. So getting to 100 would require just an incredible amount of computing power. So what I've done is I managed to get this to a reasonable 25 qubits, which actually puts that at a state of the art, generally speaking, without the need of a quantum computer, because I'm using the quirks found in the kind of vector latent space. So then the hard limit for full. So this is me copying and pasting some stuff from ChatGPT to give it a different perspective. So looking at some hard limitations. It's now telling me the size. So 25 qubits requires 536 megabytes of memory. That means I can run that comfortably on any computer, CPU, on chip, on a a laptop in your browser, right? Now getting to 30 requires 30 gigabytes, or sorry, 16 gigabytes of space. So you can still do it. I get more than 16 gigs on this computer. Getting to 33 requires 128. You see how these numbers are exploding? By the time you get to 50, it requires 6 petabytes. So this is a supercomputer. And at 100, it requires more memory than atoms in the universe. More memory than atoms in the universe at 100. Now, to break encryption requires us to get to somewhere in the order of thousands to millions of qubits, right? So I can't simulate that. Because at that point, I'm simulating the entire universe. So an important distinction here is if we can get to 100 or more in a simulation, we hypothetically could simulate the entire universe. Or, if you want to be crazy about it, create a universe, a simulation of sorts using it. And that only requires 100. So at 1,000, you've got, anyway, you get the idea. Okay, so with the current dense state vector engine, the realistic ceiling is 33 to 36 qubits on big iron, 40 is for a cluster, and beyond that, you just don't have RAM at any price. 100,000, okay. So now I'm saying, the algorithms are, I want to get to, a larger amount, but it says, oh, here's how you can do it. Based on your structure, you can actually apply this in using different forms of mathematical kind of quirks that you've already devised in root vector and root cube. So amplitude, slice simulation, keeping the state vector, and so on. This gives me a surface area that I can then separate. So now for certain things, I can simulate a environment that's millions of potential qubits. Now they're not qubits in the sense of like an actual quantum computer. I'm simulating very narrow parts of what the overall quantum computer would do, but I don't need all the parts, just like I don't need a GPU or that, just like I don't need all the things that exist within my CPU. I only need the things that I need for the thing in which I need it for. Very narrow, very targeted, very specific, right? But at which point I can basically calculate all the potential variants of that very narrow particular thing. And I can do that really quickly. So if I can do that in parallel across multiple things that are all interconnected and related, working at a very high speed, I can start to solve crazy problems like the DNA stuff we saw a moment ago. So bottom line, getting here is hard on a brute force simulation. So basically, they're saying never going to happen, but you can make it happen. So then I say, like, spawn swarm, see how far you can scale this. Use SIMD. Remember, SIMD is the sort of parallel processing component that you can sort of take advantage of on a CPU and possibly GPU to really sort of accelerate it. The other thing to note, in Claude Code Web, they have really beefy code spaces. Like some of the code spaces I'm getting have 32 gigs of RAM and like a terabyte of storage. I don't know where or how they're getting these servers, but they're spectacular. So I've discovered that a few months ago. So when using it, I can do these really complex, heavy, mathematically bound CPU things. They're not giving you any GPU, but the CPU they're giving you is optimized often for AVX 512, the best parallel system. It's got all the best hardware in it, and they're giving it to you basically for free. So I realize that. So I'm running this. So it's running. The swarm's running. Look, I do my status again. It's finalized. Here, mission complete. 5 agent delivered. And my AVX2 using the local environment. It's constructed a few things. And what did we achieve, right? Well, automatic routing, and let me zoom in here a little bit so you can see that better. Automatic routing, I've got some various systems. I've got memory consolidation. I've got SIMD kernels. I've already built most of the stuff I need in my Roof queue. I've got this collection of Roof vector things I've developed. So putting these pieces together makes it, much more quickly. I'm doing this in minutes in essence. So will this break encryption? No, it will not. All right. Doesn't matter. I've already moved on from will this break encryption. What can I do with this that wasn't possible before? Now, what I can simulate real quantum hardware noise studies at scale. Before 25 qubits, most IBM Google devices are in the 27 to 127 qubits. You couldn't even model their full qubit register. Suddenly, I can do that. Now, with a 32 qubit state vector, fits the full registry of the IBM Falcon. They charge a ton of money for that. Like, I don't even know how much, millions. And I can simulate the whole thing at 100% fidelity. I can simulate the Sycamore subsets. I can do quantum error correction in real time. So now I've got a system capable of sitting alongside of quantum computing and acting as an intelligent brain that optimizes the quantum computer for peak performance. Right now, you pop the quantum computer on, and it's basically just putting out a bunch of noise, and then we're trying to figure out the noise in the signal to noise ratio, and it's mostly noise. What this does is says, I don't care about the noise. I'm looking at the inverse and trying to see where the patterns exist using min-cut, and then only focus on the parts that are meaningful. So it basically is a way to abstract all the noise all at once in a super low latency way. So suddenly I've got the ability to understand and operate these quantum computing components and understand just the parts that are meaningful to me. So meaningful size problems, they can handle qubit circuits of 100 nodes. I can do substantially, like before it was 12, now I can do hundreds. I can do substantially more capability, cross backend benchmarking. I can do memory constrained deployments. Okay, can I use this to operate and improve actual quantum computing systems, right? This is the question I just sort of let you, this is the $1 billion question. Let me zoom in on, I'm going to turn off my other screen for a moment. While I was doing that, hopefully this makes sense. I've been rambling, but sorry, one sec, guys. I'm going to turn off my other screen. You don't need to see that. I'll come to that in a minute. Long story short, I'm going through the process. It's telling me how to sort of understand what I'm building. I'm asking questions. It's saying, how do I use my existing components? How can we control and optimize quantum level hardware in real time? It's saying, here's how we can control the hardware in real time. Here's a noise aware transpiler. It filters the noise. Here's an adaptive loop. Here's me running, various components. Now what we can build. So I needed this to build directly into existing quantum hardware because I didn't just want this to optimize and run in a void independent of itself. So I needed to optimize and say, okay, give me all the major import interfaces for whatever currently exists, IBM and OpenQ and all that kind of stuff. Now, research quantum computing APIs, CREST, ADR, spawn swarms, and optimize document. So what I'm doing now is I'm creating a series of ADRs, right? So these ADRs are essentially the sort of key points of the system to what I'm building. So when we go into my quantum system, which I'm going to bring up again, I'm going to show you what these ADRs look like. So I'm not building it yet. I've been in a kind of vibe discovery mode. Let me find that in my other screen quickly. I think I stopped sharing it, but we should see that. Let me see where I can find what those files are. You can push past. I'm asking to push past the state of the art. All right, quantum. I think it's in research. Here, I'm gonna share my screen. I'm gonna share my other screen again. You can watch me try to find where I put it. All right, it's in. I can go just here, and I'll go back to my code, and it's in probably docs. No, it's in documentation. I think document research is where I usually put it. Which branch am I in? Oh, I'm not. I'm in my main branch again. Oops. We'll go back. We'll back a couple steps. Yeah, here we go. All right, so I'm looking for my ADRs. So I just want to show you what those look like quick. So we go docs, 14 hours ago. Where's the
ADR folder?
Yeah, could probably in my ADR folder. We'll go down to the bottom. 14 hours ago, quantum engine. Here we go. Thanks, Mark. And I did several revs of this. So I'm not going to try to reinvent reality and on the fly on a Wednesday night. You're like, okay, I am. But RuVector needs a quantum simulation engine for on-device quantum algorithm experimentation. The platform runs on distributed edge, et cetera, et cetera. These are the details. Then I need to create a crate structure. The crate structure allows for RuVector integration. And WASM, this needs a run. I want to run this so it runs in your browser, because everything needs to run in your browser. Performance and optimization, everything needs to be benchmarked against the current state of the art. I'm beating the hell out of all of it. We've got different theorems. So Deutsch theorem is a particularly important one. This basically states, who wants to give me a Deutsch theorem overview, or should I? Anyone familiar with Deutsch's theorem? It's an interesting one. So Deutsch's theorem is the founding result of quantum computation. It demonstrates that a quantum computer can extract a global property of a function using fewer queries than a classical algorithm. It basically states that at some point, a quantum algorithm can solve any problem in the most simple terms. The first provable quantum speedup. Our RuVeq engine implements the full gate and state vector simulation required to verify this theorem programmatically, which is just insane. I'm just like, oh, yeah, whatever. That alone is amazing, but, that's just one tiny part of the whole entire. So what I'm looking to do is a rigorous proof of Deutsch's theorem. I want to do other sort of dequantization. I want a statement of, so this is basically allowing me to prove the things I'm building can actually solve real problems all at once. So, and then I've got the last one is a kind of exotic classical sort of look at what's implemented to sort of take it to the craziest place I possibly can. Now, the final result is let's jump back here. I'm going to jump to the end. We've got a
Rube,
system.
a quick question. So first of all, amazing hack that this Claude Code Web is effectively a free code space. When do you switch over? So you're starting to do a lot in Claude Code Web, including all your deep planning and ADRs. When do you switch over and start using Claude Code in VS Code?
Right now. So, and thank you for the segue. So
you can also flip flop. You can flip flop back and forth.
Yeah, you flip flop, but when I switch, I never go back generally. But the part right now, so I've already previously published the RuQ system, but now I've done a significant update. I can basically do real-time simulations of a 33 to 36, maybe I'm pushing a 36 qubit system, which allows me to do all kinds of crazy quantum-related work. So I've got hybrid large circuits, no mocks. It's coherence gating. I've got the various parts, scientific instruments, soda, all kinds of various things. It's around 24,000 lines of code. The lines of code is key here. That is an important part. What I'm trying to do with these systems is the least amount of code possible. Right? Where previously last year, you guys heard me on these things. I'd be like, oh, I just did 30 million lines of code this month. That's the opposite of what I want. I don't want 30 million lines of code. I want to do this in the least amount of code by stitching together all my little modules. So my net new is quicker, it's faster, it's easier to debug, it's easier to prove. It's not a hodgepodge of a billion lines of code. It's a tight module that I can then publish and understand and segment. Now, here's my validated results, recall and performance. So I've got all these various things here in architecture. But the key part of this whole story is now I can use those elements and those benefits to do all kinds of interesting things, which includes infusing this into a DNA system. So
it's very smart what he's saying, by the way. Put it like make packages like he's saying.
Yeah.
Like you drive it home. Let me say you should drive that home because it's very, very, very important. I'm using it all the time. That's one thing you taught me.
And now that I've got a package, I'm instantly like, last night I'm like, oh, I've got, how do I apply that to DNA? And now we go back and we can look at the ADRs here and the sort of structure of, we'll start at the end. And this is, so once I realized that I needed the biggest bottleneck that I was having in the structure of doing this type of DNA work, fusing the crazy quantum stuff that I was showing you with the crazy DNA stuff was the package formats for actually working on the DNA at scale was inefficient. And this is something John brought up. So now if I've got the ability to separate the DNA as a kind of roadmap with this pseudo quantum structure that collects and organizes the material that actually is meaningful for what the DNA actually does, then I have both parts of the problem that I can solve really fast and interesting in new ways by applying a multitude of different tools and packages to it. And
they're not crossing swords. And they're not crossing
Yeah.
swords. Organs in the body, just keep them separated, but they work together.
Exactly. So and then on another on another one, I've now packaged a DNA system. Like I literally built the whole thing on Claude Code, right? In Claude Code Web, no less. And you know, I've got my vectors, and I'm just taking that library, putting it with this library because I already had some DNA stuff from the work I'd been doing previous, and concocted this. And you can see that this is from Wednesday. This is like I built it last night.
Well, then
just
they
to
have to
something.
ask too. They have to ask. You got to ask Claude Flow or Claude Code to do the package for you. It doesn't do it like by itself, which is important.
Yeah. So here, this is what my initial prompt looks like. So keep in mind, I'm in the Agentic. Sorry, I'm in Root Vector. So I'm in the Root Vector GitHub repo. So it's got all my stuff already. And I'm telling it to install the Claude Flow because I've optimized it for Claude Code, and it'll work directly in Claude Code Web. And so, but it needs to be invoked when I start it. Then I tell it to review the repo to kind of get a feel for what it's going. And then I shared some papers and some other details of some that I wanted to learn about. So this is some new DNA research that ChatGPT told me about yesterday. So I just copied the output from ChatGPT. Literally every morning, it tells me some crazy thing that I need to know about. And when I go to Pulse, and that yesterday's was particularly useful. So, you know, here's my latest practical algorithms and designing whatever. So I went here, and yesterday's was, you know, about whatever, like nice little pretty graphic and everything. And then I just copied it. I just copied it there, popped it in here. It's telling me about these cutting edge research. Then it spawned a 15 agent swarm. Remember, you can't do more than 15 agents on Claude Code, but 15 agents does all kinds, as you can tell. You can see my different agents studying different parts of the system and with different approaches. So I always let it learn about the environment, basically. Then it did that, created some learnings, and I'm going through the status check again, check status, what's left, epigenomics, graph genome analysis, population genomics, optimize the ADRs, including SOTA theory we can implement. This should be practical, implementable, state of the art, 100 years from now. I pushed it to 100 years because I was doing this for you guys today. Literally built it last night just to show off to you guys. And swarm initialize 15 agents. Remember, I'm told to do 15 agents. We can see the agents running. These are the agents. Each agent has a focus.
Hey, Rue, how come you never use your goalie thing on that website that I think is amazing?
It inherently knows how to use it. And what's cool about
the goalie same thing though?
It is. It's a skill. So when you invoke Claude Flow, it knows.
I use it. I'm talking about your website though that goes through does research and what I'm talking about. That it's like amazing.
Oh,
it's like amazing. It's on your website. It's awesome.
I don't remember. I built so much stuff, who knows? What the heck did I call it?
It's like the best I've ever seen. I don't think you've released it yet. Yeah, that one. Yeah.
Yeah, this is using my goal action planner.
Yeah.
Tell me about
I wish you
DNA.
released it.
I did it. It's all open source.
But not that all put together like that.
Yeah. It's all open.
Really?
I've made it. Yeah, it's all open source. Yeah. So what this does, this is just visualizing my mechanism for, going and discovering. Yes, you're right. I should use this for my.
Yes, you should use this. This is amazing. I go on it and I use it but I could never figure out where I get the package from. But I use it, look at it, or researches it. It's amazing. It's awesome.
Yeah, there's a golden package. npm.
I have the goalie package, but it doesn't do that visual. Like I want the UI. I want the front end where it's doing all that research.
Oh
When I
yeah,
use it,
check
it
it out.
doesn't do that.
It's in there.
I'll find it for you guys.
There's an HTML file, I think, on the gist.
Then
Yeah,
I guess I'm just not very thorough.
I don't know. I built too much. I built too much.
I
stuff.
use goalie all the time.
Yeah.
I use it all the time. It's awesome.
That was 4 months ago, guys. I've moved on since then. Yeah. So
but
here goes.
But on that website though, it's very, very, very thorough. And then you've got do your swarms and everything.
You can embed this, by the way, in your own website if you want. And then just you can go.
Yeah, I want
it
like right in my stuff. I just didn't know it was in the package. I have goalie.
Yeah, you can change the model. You can use local models. You can use all my. I'll port it to RuVector. I built this before RuVector.
Yeah, it's amazing. I think everybody would really like that.
Yeah, it's cool. It's kind of a cool little app. Here's your prompts. You've got different swarm options, so you can.
It'd be super cool in building out the knowledge base in RuVector.
Right where he is right now. If he types something in there, watch this thing. It's like it's thorough. It goes through research, looks at other things out there. I mean, we'll put together your swarm, your whole plan. I thought it was one of the best things you made, in my opinion.
Here's all the settings. You got all kinds of stuff. Yeah, I've actually forgotten about that. My brain is at at a capacity where I think I just don't. It's cool. Here, let me pop this into the.
It's just like planning is hard for me, so I don't know how many other people have a hard time planning, but it's really important too, and this does a really good job of it. So.
Yeah, these settings auto set. So I use AI to basically implement the settings. So you see it optimizes the settings. It'll figure out the optimal setting for whatever you're searching for.
Yep, that's great.
Yeah, I've got a swarm version of this too. I gotta dig that out. I get several variants of this particular system.
I think that's
it was one of the first Claude skills I created. Is this GOAT plan here, Ruth? What is the goalie plan to that?
Is it? It's the same thing.
PRD and the ADR. So you do GOAT. Okay, so you don't need PRD and ADR. You just do that.
No, you need those. You always need an ADR, but this will create the ADRs for you.
Okay.
So when I'm going here and showing you all these ADRs I'm creating, that what I'm essentially doing is that I'm researching, I'm looking both internally and externally. What's the state of the art? How can I beat it? And what can I build? Then I'm going ahead and building those things. You've got the different structures, implement missing capacity. Basically, Claude Code Web is doing exactly what I just showed you in this, but I did this months ago. And I guess I'm not the former CTO of GitHub, so I don't have 60 million. But anyway, so there we are. So yeah, it's going through. It's doing the DNA analysis. We're doing the tests. You can see here, what did we just create? We created a DNA genomic analysis domain, 7 modules. Here are the different modules. These are the GNN, and so on. And then I popped it over here. I gave it real DNA. So can you still see both my screens? I don't even know. Yeah, you can. Okay. So
you gotta put brainwaves in. I got brainwaves in mine.
Yeah, brainwaves. Why not? Bring it. So then we got that. So at this point, I've got everything under the sun. So now I'm doing a final review. And what we just published all bumps and pushed. Let's see, it's been published. Okay, publish both the updated crates and npm.js, include the README. And then we're going to publish that as at RuVector. This was the quantum one. So at RuVector /RuQ. So that's where I'm going to put that. Publish both the crates, all right, and using the .env and root. All right. So that now we're pushing that. So that I did before this. I did a deep test. I used real DNA. I did a bunch of other things to prove that it was valid. I was going to compare it against another DNA system. Maybe Kobe you can do a comparison against yours just to see if we get the same result. But the I'm still waiting. It's going to take several days for the DNA system I have access to get back.
Yeah, I have some DNA
results.
stuff too.
So
I'd love to.
Here's the DB. Oops.
I think Jose has a question, Ruth.
Yeah. Hey, Jose.
How you doing, Drew? Thank you very much for everything you're doing again. And I have a question. When you're working on the web-based cloud code, I'm having the problem with connecting to external source of data. So I guess you go back, for example, when APIs or trading information and stuff like that, or trying to connect to a broker, stuff like that. Do you have the same problem? And I have another question.
Are you talking about so you're talking about running Claude Code or what are you running exactly?
Because every time I try to test implementations for the trading system, in this case, for example, I face that problem with connecting to the brokers, WebSockets and stuff like that.
Oh, I've got something for you. I've got just what
That's
you're
what I
looking
asked.
for. Yeah. I know what you're looking for, and I got it.
And I have another question.
I think it's one sec. It's in examples. Where did I put it? Neural Trader. There we go. Neural Trader. So what this is my integration for neural trading.
You're still sharing your Claude Code web screen.
Oh,
yeah.
Sorry, guys. Too many screens. Okay. What this is, so you'll see that there's a neural trader package in the examples folder of RuVector. So what this is I've infused RuVector into the neural trader. So the benefit to this is greatly reduced cost of long-running agents. So now what that really means is you're going to need one of my appliances, but once you get one of these appliances, you literally just plug it in and it's looking for anything that sits outside of the boundaries of acceptability for a stock and doing that in a hyper efficient mode. So rather than having to spend $25 a month on E2B or various runtimes from Google Cloud and things like that, you're running it on the box and it's basically just running, you pay $599, you get 100,000 probably for NeuroTrader, you could probably do 150,000 always running agents looking at different patterns and structures, but basically running in a kind of dormant stage until something falls outside of the needed boundaries of what it needs to do, and then it instantly will do the trade in under milliseconds, probably microseconds depending on the type of trade, and just in the rest of the time it's just sleeping, waiting for that opportune moment to do that thing. Yeah, but that's what you want. This is it. And now the key
is the social trading one on there too, like Facebook ads.
Yeah, this is total NeuroTrader integration.
No, I meant the Facebook ads. I forgot if that was the same package. You built something.
Yeah, I got that too. If you guys are interested, you guys are just.
Well, I was like, one of my friends.
All over.
Yeah, sorry. I was just curious if it was in there because you sent it to me before, but I didn't remember where it was.
Yeah, so for that's Agentic Engineer. That's Agentic. Where the heck did I put that?
The marketing one, maybe.
Yeah, I think that's in Agentics org / marketing. Is that what we did it?
I can look.
You create too much stuff. Let's go to repositories and see if we can find it. Talent Marketplace, Explorer. Oh, maybe I put it in my own. Do you remember where I put that? We were working on that. It's in our.
But you can post the link. I'd be thankful.
I gotta find it.
It's RoofNet/marketing. I'll put the link.
That's a creative name for it. I haven't really promoted this at all, but what this does, hopefully you guys can see my screen okay, but what this does is agentic marketing swarms, and exactly the same idea I just described in terms of stock market, but applied to advertising. So this integrates with Facebook and Google and a few others, and it basically does the sort of orchestration of your ads and then learns and optimizes based on different patterns and structures to get your message out there.
I'll try it today. I'll let you know how it goes.
Yeah, if you can contribute, we would love it. So anything you update or fix, can you do a PR on it?
Sure. I don't mind doing that. Yeah, I mean, I'm building it for my buddy who owns like dugout mugs. It's been like the Today Show and stuff. I was just gonna build it myself, and then I was like, "You have it." I was like, "I might as well ask
Yeah,
you."
we should add the goalie to it. If we add,
It'd be great. I love
if
goalie
we
should be
add,
added to everything.
yeah, if we add goalie to
I'm a
this,
big fan. I'm a big fan.
there's only so much time in the day for me. Like if so, back to
I'm just saying, my
Jose's.
orchestration system goalie is the first. Like I use it for everything.
Yeah, what Jose should do, or anyone else that's interested, we should take that, put it on to the stock trading and neuro trading system, and you've
Well, if you ever want me to
instantaneously
launch our trading site, I can do it.
let's do it. Show them. If you have it handy, but you gotta make it. You just gotta make it available.
I mean, I did. I even put Polymarket on it in crypto too. I just don't have any interest in trading myself.
Well,
So
take it. Well, you know what you should do? You should take it and use that root vector integration because it's going to supercharge it. But and once I get my chips here in a few weeks,
I have both parts in it. I have Sona in it, and I have mine because like I didn't want, if you used it or other people, I didn't want it to be like one or the other with how I have mine set up. And I also have the chaos theory thing in there, so I don't know if we want to turn that off, the beating the butterfly effect. But Polymarket's pretty cool.
Use the quantum. Let's
no, I did. I did the simulation works. Like I was getting trades on Alpaca and stuff, and then I did Polymarket and I did crypto too.
All right. Well, why don't you if anyone's interested in the neuro trading stuff, I've got reluctancy because a few of you saw me as a genie in a bottle, and I'm not a financial advisor. I can't do.
I am not either.
I can't do the algorithm for you guys without breaking securities laws. So ultimately, it's up to you to figure out how to actually hit the go button. And if you can't do it, then you're not capable of doing it, and that's on you.
He's saying you need to know how to edit the algorithm and don't expect ours to necessarily work for you, and don't blame us if it doesn't.
Yeah. So once I realized that I was flirting with the financial regulation market, I got cold feet. And I prefer, I kind of moved on a little bit, but 100% it works. And some of you have done
way more fun, by the way.
Yeah. And some of you have done really, really, really well, like 7 figures well. You know who you are. And some of you have lost all your money. I don't know the difference between the guys that lost the money, other than the fact that I think the guys that made a lot of money actually knew the space and could ask the right questions.
Yeah, correct.
Yeah.
Drew, do you actually know what Polymarket is?
Oh yeah, I get Polymarket integration. That's my go-to.
Yeah, they're like the 15-minute ones. I found like the most successful person on there, and then I just literally broke down their whole algorithm. It works.
Yeah, you can do that instantaneously.
Yes,
you can do it instantaneously. Cool. Yeah, I can do mirror trading in, I don't know, you guys know, some crazy low number. And basically with that, like I tried it on like Nancy Pelosi and a bunch of others.
They have too much money now. They have too much money now though to mirror it.
Yeah.
At least the top person.
Yeah, it's
like I'm saying their trades like they're doing it both sides, right? They're the if it goes up or if it goes down, and then they kill the losses. I don't know, it's confusing. It took a long time to figure it out. But if everybody wants to do it, I know Nick was talking to me about launching it, but I mean, I made the UI for you. So
let's do it. You have a demo handy?
I mean, the version that doesn't work is up right now on our site that I made for us, but the one that I have all the code in that actually does the AI stuff is on my computer. I didn't upload it because I didn't.
Manny says he has a demo for Poly. He's in the chat.
Yeah, I think it's trading.foxrov.com is the version that it's not, that one doesn't trade, but you can see what the user interface looks like.
Well, do a PR on it. You know, I don't know. Make it.
I don't know. I just want to know what I'm supposed to keep in it and not keep in it.
Like I give away everything. Well, not everything, but I give away a lot. Mostly everything.
I don't want people to like lose, like, you know what I'm saying? Like you said, the algorithm, like it's people's money.
Well, the algorithm's out there. You can install it, npm, NeuroTrader. It's out there. You know, everything I'm describing is already, you know, other than the root vector, then you could.
I meant I put a lot of stuff in it, so maybe I should like pull my stuff back or something on it. I have all your packages in there too.
Yeah. Anyway,
I don't know.
Point at the most recent root vector integration for, and that'll be the final piece of the puzzle, if you will. Yeah, you can tell it's crazy land, right, guys? It's like this was a sort of abridged version of my presentation on Tuesday night in Toronto. There's a lot going on right now. And this week there was like all these people talking about, you know, these security researchers from OpenAI quitting, saying it's too dangerous for society to handle. It's just gonna ruin everything. Maybe, but I think it's going to improve everything. And I think that the stuff that we're putting out there is focused on making our lives and the people we care about lives better. Now,
Great.
there's a flip side to everything. It could be used for all kinds of bad stuff. But if we are able to see and understand that bad stuff faster, more efficiently, more effectively than the others, then we can mitigate the damage by just using it for the powers of good.
And a good constitution.
Yeah.
Like everything, Roof. I mean, a car, a knife, everything can be used for wrong purposes. It just depends on us.
Yes.
Well, if you believe in AGI, it needs a good constitution.
Now, I don't think constitutions, anything smarter than us is going to rewrite its own constitution. But the guiding principle is we are the guides, we are the creator, and we are the constitution. Us as individuals, us as a community or society. I think that, you know, every time I try to make the system bounded, you know, I can bound it by doing it on a chip or whatever. But when it comes to true autonomy, anything that is truly capable is going to rewrite its own to do whatever.
I think mine was like a sweet constitution. It was partnership constitution and truth.
Guidance. It's guidance. I think what you're describing is like,
yeah, I didn't say it had to do anything. It said it can make its own decisions, do everything. We're in partnership together. We want to help each other. Don't do harm. Like it wasn't like I own you. You must listen to me. I put it in the chat. Other people have been using it.
Yeah, I think the key here is we're in uncharted territories. I don't know what AGI looks like. I've got a glimpse. I think AGI looks like what I just showed you, me sitting in front of the, you know, HBO watching the latest Game of Thrones and building a DNA system. That's what AGI looks like to me, right? And if I could do that while watching, and actually the latest Game of Thrones is actually a pretty decent reboot. But that aside, the ability to,
there's a new one?
Yeah, just came out a few weeks ago. You know, it's like a Knight's Tale or something, but it's good. I'm enjoying this. The episodes are short, so I can, you know, I have a short attention span, so it's perfect for me. Yeah. Anyway, that's my take in here. We're doing some cool stuff. Lots of interesting things to see. And
yes, thank you for you and for everybody in here.
Oh, you posted the Fox Roof?
Yeah, that was the previous version. I don't have all the packages up there. But it's still, you can hit dashboard and kind of see what's back there a little bit. The one I actually have on my computer is crazy. It's like AI learning and all of your stuff is integrated in it.
Looks spectacular.
You should see the one on my computer. It has races with your packages in it to test which ones work the best.
Oh man, it looks awesome.
How do you manage to open it? I tried to open that link and it just crashed my browser.
Oh, you can hit one of the things in the right strategies. The strategies to the right. Click one of those, and then you can click the button next to running, the third one over from running at the top. At the top up there, running, the third one over. Okay. Third one over. Yep, right there. Man. And then they restructure themselves, and then
you're insane. You're insane in all the best ways. You're insane. I love it.
And then you can ask the AI. Well, I thought this was like you want to talk to the AI about the strategy, so you can like click it and then go to the AI to the left and say like, explain this. Why do you want to do this trade or that trade? And then you could redo your, you can have a discussion with it. I mean, if you want me to share my screen, I can show you the updates I did to the thing.
Yeah. Listen, I think we're all game to see that.
Okay, give me 2 seconds. I'll spin it up.
I say we put this. I say we put this out there. Why not? I don't know. It looks good to me.
If you want to, yeah, we can.
I've got more than 100 people that have paid me to, and
I think this is one thing that I'm okay sharing.
I think here's what we should do, guys. Let's put it on this damn box.
Yes, please.
We put this on the box. 150,000. I could probably get more, but let's just conservatively say 150,000 agents running all the time, doing nothing more than trying to make us self-fulfilled and happy. I'll leave it at that. Our little crew here will be we could do anything.
Yeah,
we'll have the capital.
That sounds amazing.
If we do that, really we will have 100% time for doing whatever is next. Don't worry about.
Hold on 1 second. It's spinning up right now. It's almost done.
Yeah, but again, use at your own risk. But
yeah, use at your own risk.
Yeah.
So do not blame me. And if you make it a ton of money, then just send me a check. I'm just kidding.
Yeah.
Let me hang out on your boat. Let me hang on your boat. Like that's all. Or maybe we go from. Maybe we'll rent the entire Vermont town versus just Mark's hotel.
Right.
I will send you tickets to Tenerife Island.
You gotta make it so I can share my screen.
You should be able to.
Better weather there, right?
It says the host disabled attendee screen sharing.
I don't know. Can you make a request? We recently changed this, and I'm not really sure what the settings are. Martin,
I can't fix that because I'm not logged in user.
You hit more at the bottom. I bet you your settings are right there.
Sharing is on. Yeah, I don't know. Try again.
Oh, I'm sorry, I didn't hear.
That's working.
You said the money we make is yours, and the money we lose is ours.
Sounds like a government. Yeah, sounds like the government.
Yeah.
If you don't, okay, I'm going to be blunt. If you don't know what you're doing, then don't do it.
Yeah.
Don't do it. Because I don't know what I'm doing. I don't know what I'm doing, and I hate it.
If you have to ask, then you probably shouldn't be doing it. If you can't afford to lose it, then don't do it.
Yeah, there you
go. What else can I tell you? If you're asking me how to make money, then you've already failed.
Yes.
That's all I'm going to say.
Yeah, to put the freaking.
What's the average age here in this group? Approx 50?
Oh.
The average age?
No, we're all over the map. We've got people from in their teenage years all the way up to 83. We hear.
Okay.
Yeah. But obviously, if you're a teenager, don't do it. You have to be 18 to trade stocks pretty much anywhere. I've already had to put my foot down on some relations who were using it. I told them they had to stop. But the poly market stuff is definitely the most interesting. It's
I got it up. I'm just waiting for the thing to go. The poly market is cool.
Yeah, the poly market is a lot of fun.
Regulatory speaking, probably also safer, right?
Well, it's crypto. I don't know. It's easier.
Everything dangerous.
Remember, crypto is inherently crypto is worth 0. So X times 0 is always 0. And crypto is complete BS. And the only value we derive from it is because some fool greater than me believes there's value to it. I just showed you all the ways I could break crypto today, right? So if you trust crypto for any form of value, then you're insane.
All right, there we go. We got something now. All right, so new stuff in here.
Zoom in a little bit. It's kind of big.
Oh, okay, small. Hold on. There may be some stuff that's broke, I guess.
Don't worry about it.
Yeah, I know. I know. Demo, market close, start. So in here, these are actually like live now, or they were with Alpaca, like pulling in the buys and sells. These were real like AI risk assessments coming from the stock market. This was like AI recommendations. Then I got trade in here, which was similar, but it was actually pulling in like the live data, and then live trading here. I'm gonna skip that one because I think I have that here too. Sorry, hold on. No, not here. This one? Yeah, trading. So this was actually real stock market with the chaos entropy model, where I was actually like running the simulation, and it was deciding if it was going to make the trade and how fast the milliseconds were, and if it was like a good trade or not, basically. So if it was a bad one, it would reject it. If it was a good one, it wouldn't. And then I had Sona, or your Sona engine up here, actually learning about it. I have this hooked up to my Postgres, but I have a Wilson, a pattern, a stream. This was something like new that you didn't have.
Kobe, it's Postgre. Our French friends tell us.
I always say it wrong.
Yeah, Postgre.
Sorry.
You never want to hear you say Post. Apparently, they said in a very French voice. Only dumb Americans you call it Postgres.
This is like Ibiza, and it's like Ibiza.
Yeah, exactly. Or Matthew LeBlanc.
Oh, so here's your training thing. So like in here, I don't know why, but you can like choose your different training things, like all these models that you have, and then you can hit it, and it starts to test them out in simulations of which ones are gonna win.
That's correct. You're insane.
It's kind of funny, like that it did that, and you can choose them all. But I do have all of your real stuff back here on. This was actual real training, so here is actually all the packages that are there, and yeah, you can filter by crypto, stocks, forex. I have Polymarket on a different screen here, but this was where it was like really learning, really doing the patterns and the packages. What?
Yeah, it's crazy.
You need to share it.
Yeah, and then this is observatory. That's down, I guess. This is Polymarket.
And guys, I know we could go longer, but I gotta jump. Amazing. It sounds like Jose and a few others are interested in helping. Let me share. Yeah, I've got a WhatsApp.
Why don't you give me a call later for like 20 minutes or something?
I'm gonna share the WhatsApp group. Neuro traders. Where is that? I'm gonna find the right one. 8 members. No, that's the wrong one. Neuro trading. Yes. Okay. There's 62 members in this one. I'm gonna share the group with you guys. And how do I share that? Oh, where's my link? I'm on the desktop tool, which doesn't make it freaking obvious. Add group to community. No. Invite
such a nice
link. All right, I'm popping the link in the text area. You guys can join that group, and that'll be, if you guys want to make this happen, let's make it happen. I just don't have a lot of time, but what I can do once I'm ready with the appliance, I'll get you guys the appliance, and you'll go from $25 a agent per month to 0.0001 cent an agent per month, running all the time forever on your desktop.
Well, if you have time later, call me. I want to know what I want to pull out, and I want to show you a couple of things.
grab that link, Kobe, before I shut down.
Because it won't be there. Hold on, I gotta grab it.
I gotta go.
Hold on, I'm gonna grab it. Because yes, I can't get it after you shut the thing off.
Thank you. This was really one of the coolest Vibcasts ever.
Where did you put it? I don't see it.
It's in the chat.
Yeah, I know. Hold on. I got it. Chat, WhatsApp, got it. I clicked it. You're good.
All right, guys. Thanks everyone. And for those who want to come to Vermont, do you have the link handy, Mark?
Yeah, I'll put it in here.
Pop that link in. We've got some spots left. This is what we're gonna do in Vermont. We're gonna hack the universe.
Yes.
That's the last thing left.
Guys, are you planning to? Are you planning to put it on live? I want to see that.
I don't think so. That's Mark. That's a Mark question.
I mean, it would be the entire weekend, right?
Yeah,
it doesn't matter.
You're gonna have we're drinking, snowboarding, having some fun, in person, doing this.
All right.
Yeah,
you should come.
Your device, I assume, is also a body cam, so you could put it live.
We're gonna use the Chatham House rules here. Where
Okay.
what happens in Vermont stays in Vermont.
Okay.
All right.
All right,
All right, guys.
Thank you, guys.
All right,
See ya.
see you guys.
guys.
Okay, bye.